Welcome to the ISTQB CT-GenAI exam prep series by AmitAutomates. In this video, Chapter 1, Introduction to Generative AI. You will practice 30 questions, each with 4 segments. The question is read aloud, then a pause screen gives you time to choose, then the correct answer is revealed, then a full explanation follows. Every question shows its learning objective code and K-level. This content is based on the official ISTQB CT-GenAI syllabus. Let's begin. Question 1. Learning Objective GenAI 1.1.1. Difficulty level K1. Which of the following correctly pairs an AI technique with its primary characteristic? Your options are A. Symbolic AI uses neural networks to automatically learn features from raw data. B. Classical machine learning uses deep learning techniques to create new data patterns. C. Deep learning relies on rule-based symbolic logic and explicit knowledge representation. D. Generative AI uses deep learning techniques to create new data by learning and mimicking patterns from training data. Take a moment. What is your answer? The correct answer is option D. Generative AI uses deep learning techniques to create new data by learning and mimicking patterns from training data. Explanation. Generative AI uses deep learning techniques to create new data by learning and mimicking patterns from its training data. Symbolic AI uses rule-based systems. Classical ML uses data preparation and feature selection. Deep learning uses neural networks to automatically learn features. Low GenAI 1.1.1 K1. Question 2. Learning Objective GenAI 1.1.1. Difficulty level K1. Which AI technique relies on predefined rules and logical relationships to solve problems without learning from data? Your options are A. Deep learning, because it processes structured rule sets through layered neural computations. B. Symbolic AI, because it uses explicit knowledge representations and logical rules defined by humans. C. Classical machine learning, because it applies statistical models to encoded rule patterns in datasets. D. Generative AI, because it generates outputs based on rule-constrained probability distributions. Take a moment. What is your answer? The correct answer is option B. Symbolic AI, because it uses explicit knowledge representations and logical rules defined by humans. Explanation. Symbolic AI relies on predefined logical rules and explicit knowledge representations created by humans. It does not learn from data. Deep learning and classical ML both learn patterns from data. GenAI creates new content based on learned data distributions. Low GenAI 1.1.1 K1. Question 3. Learning Objective GenAI 1.1.1. Difficulty level K1. A tester is asked to recall which branch of AI automatically extracts features from raw data without manual feature engineering. Which is it? Your options are A. Symbolic AI, B. Classical machine learning, C. Deep learning, D. Rule-based AI. Take a moment. What is your answer? The correct answer is option C. Deep learning. Explanation. Deep learning automatically learns hierarchical features from raw data through layered neural networks, without requiring manual feature engineering. Classical ML requires humans to define features. Symbolic AI uses rules. Rule-based AI is another name for symbolic AI. LLM-GenAI 1.1.1 K1. Question 4. Learning Objective GenAI 1.1.1. Difficulty level K1. Which of the following correctly identifies the primary purpose of classical machine learning? Your options are A. Generating new content such as images, text, or code by learning patterns from existing data. B. Encoding expert domain knowledge as logical rules that a computer can apply to solve problems. C. Learning patterns from labeled or unlabeled data to make predictions or classifications. D. Processing raw data through multiple neural network layers to automatically extract complex features. Take a moment. What is your answer? The correct answer is option C. Learning patterns from labeled or unlabeled data to make predictions or classifications. Explanation. Classical machine learning learns patterns from labeled or unlabeled data to make predictions or classifications. Option A describes GenAI. Option B describes symbolic AI. Option D describes deep learning specifically. LLM-GenAI 1.1.1 K1. Question 5. Learning Objective GenAI 1.1.1. Difficulty level K1. A test manager asks the team which AI category includes technologies like Stable Diffusion, GPT, and Dolly. Which is correct? Your options are A. Symbolic AI. These tools apply expert rules to generate structured outputs. B. Classical machine learning. These tools classify inputs into predefined output categories. C. Deep learning. These tools process multilayered neural networks but do not generate new content. D. Generative AI. These tools create new content by learning and mimicking patterns from training data. Take a moment. What is your answer? The correct answer is option D. Generative AI. These tools create new content by learning and mimicking patterns from training data. Explanation. Stable Diffusion, GPT, and Dolly are all generative AI tools. They create new content, images, text, code by learning patterns from large training datasets. They are not purely symbolic, rule-based, purely classical ML, classification-focused, or restricted to feature extraction without generation. LLM-GenAI 1.1.1 K1. Question 6. Learning Objective GenAI 1.1.2. Difficulty level K2. Which statement best describes a key limitation of context windows in large language models? Your options are A. Context windows control the temporal sequencing in which tokens are generated by the model. B. Context windows determine a model's ability to reference and cross-link multiple documents simultaneously. C. When text exceeds the context window size, the model cannot process all parts simultaneously and must discard tokens outside the boundary. D. Context windows define the parsing approach used when the model analyzes syntactic text structures. Take a moment. What is your answer? The correct answer is option C. When text exceeds the context window size, the model cannot process all parts simultaneously and must discard tokens outside the boundary. Explanation. When text exceeds the context window size, the model cannot simultaneously consider all parts. As the model processes new tokens, it must discard tokens that fall outside its context window boundary. Context windows do not control temporal sequencing, cross-document referencing, or parsing approaches. LLM-GenAI 1.1.2 K2. Question 7. Learning Objective GenAI 1.1.2. Difficulty level K1. Which of the following best describes tokenization in the context of large language models? Your options are A. The process of mapping text into dense numerical vectors that capture semantic meaning and relationships. B. The process of splitting text into smaller units that represent the building blocks of natural language, enabling LLMs to understand and generate text. C. The general mechanism by which LLMs process natural language prompts and generate contextual responses. D. The probabilistic method by which LLMs predict and generate successive words in a sequence. Take a moment. What is your answer? The correct answer is option B. The process of splitting text into smaller units that represent the building blocks of natural language, enabling LLMs to understand and generate text. Explanation. Tokenization involves splitting text into smaller units, tokens, that represent the building blocks of natural language generation, enabling LLMs to understand and generate text. Option A describes embeddings. Option C describes the general LLM function. Option D refers to next token prediction. LLM-GenAI 1.1.2 K2. Question 8. Learning Objective GenAI 1.1.2. Difficulty level K2. A tester notices that an LLM loses track of instructions given at the start of a very long prompt. Which concept best explains this behavior? Your options are A. Tokenization. The model converts early instructions into tokens that conflict with later tokens. B. Embedding drift. Numerical vectors for early tokens gradually shift in meaning over time. C. Context window limitation. As new tokens are added, earlier tokens fall outside the processable window. D. Temperature variance. High temperature causes the model to randomly disregard earlier context. Take a moment. What is your answer? The correct answer is option C, context window limitation. As new tokens are added, earlier tokens fall outside the processable window. Explanation. When a prompt is very long, early parts of it may fall outside the model's context window as new content is added. This means the model effectively cannot see those earlier tokens anymore, which explains why it loses track of earlier instructions. This is a direct consequence of context window limitations. LLM-GenAI 1.1.2 K2. Question 9. Learning Objective GenAI 1.1.2. Difficulty level K1. Which statement about embeddings in the context of LLMs is correct? Your options are A. Embeddings split text into discrete units that serve as the basic building blocks for LLM processing. B. Embeddings are dense numerical vectors that represent tokens and capture semantic meaning and contextual relationships. C. Embeddings control the probability distribution used by LLMs when selecting the next token to generate. D. Embeddings are the explicit rules encoded into LLMs to guide correct language generation. Take a moment. What is your answer? The correct answer is option B. Embeddings are dense numerical vectors that represent tokens and capture semantic meaning and contextual relationships. Explanation. Embeddings are dense numerical vectors that represent tokens in a continuous vector space, capturing semantic meaning and relationships between concepts. Option A describes tokenization. Option C describes what temperature softmax influence. Option D describes symbolic AI rules, not embeddings. Low GenAI 1.1.2 K2. Question 10. Learning Objective GenAI 1.1.2. Difficulty level K2. Which of the following correctly explains why two prompts containing the same words but different ordering might produce different results from an LLM? Your options are A. Because LLMs use tokenization to split words differently based on their position in a sentence. B. Because embeddings and attention mechanisms allow LLMs to weight contextual relationships, making word order significant. C. Because the context window processes tokens in reverse order when they appear beyond a certain threshold. D. Because LLMs apply symbolic rules that are sensitive to the grammatical structure of prompt sentences. Take a moment. What is your answer? The correct answer is option B. Because embeddings and attention mechanisms allow LLMs to weight contextual relationships, making word order significant. Explanation. LLMs use attention mechanisms that consider the relationship between every token in the context window. Word order affects how tokens relate to each other, influencing the contextual meaning captured in embeddings and ultimately the model's output. This is distinct from tokenization, which just splits text or symbolic rules. Low GenAI 1.1.2 K2. Question 11. Learning Objective GenAI 1.1.3. Difficulty level K3. A test team is evaluating which type of LLM to use for two specific tasks. 1. Detecting trends across multiple test data sources and prioritizing test efforts. And 2. Generating test cases that conform to Gherkin syntax. Which pairing is correct? Your options are A. Foundation LLMs for detecting trends, instruction-tuned LLMs for Gherkin test case generation. B. Reasoning LLMs for Gherkin test cases, instruction-tuned LLMs for trend detection. C. Instruction-tuned LLMs for detecting trends, foundation LLMs for Gherkin test case generation. D. Reasoning LLMs for detecting trends and prioritizing test efforts, instruction-tuned LLMs for generating Gherkin format test cases. Take a moment. What is your answer? The correct answer is option D. Reasoning LLMs for detecting trends and prioritizing test efforts, instruction-tuned LLMs for generating Gherkin format test cases. Explanation. Reasoning LLMs specialize in synthesizing multiple data sources, logical inference and decision-making, ideal for trend detection and prioritizing test efforts. Instruction-tuned LLMs are specifically trained to follow instructions and adhere to specified formats, ideal for Gherkin syntax generation. Foundation LLMs lack structured guidance for either task. Low GenAI 1.1.3 K2. Question 12. Learning Objective GenAI 1.1.3. Difficulty level K2. Which statement best describes the primary characteristic of a foundation LLM compared to an instruction-tuned LLM? Your options are A. Foundation LLMs are trained exclusively on code repositories, making them ideal for test script generation. B. Foundation LLMs are pre-trained on broad datasets for general language understanding and generation, but are not specifically optimized to follow instructions. C. Foundation LLMs outperform instruction-tuned LLMs on all structured tasks because they have larger parameter counts. D. Foundation LLMs are fine-tuned to follow specific task instructions, making them more versatile than instruction-tuned LLMs. Take a moment. What is your answer? The correct answer is option B. Foundation LLMs are pre-trained on broad datasets for general language understanding and generation, but are not specifically optimized to follow instructions. Explanation. Foundation LLMs are pre-trained on large, broad datasets for general language understanding and generation. They are not specifically optimized to follow instructions or produce structured outputs on demand. That is the role of instruction-tuned LLMs, which have been further trained with human feedback to respond to instructions. Low GenAI 1.1.3 K2. Question 13. Learning Objective GenAI 1.1.3. Difficulty level K3. A tester needs an LLM to carefully work through a complex multi-step logic puzzle embedded in a test scenario, verifying each reasoning step before arriving at a conclusion. Which LLM type is most suited? Your options are A. Foundation LLM. It has the broadest training data for diverse reasoning scenarios. B. Instruction-tuned LLM. It follows structured step-by-step prompts accurately. C. Reasoning LLM. It is specialized for logical inference, multi-step reasoning, and drawing verifiable conclusions. D. Multimodal LLM. It can process multiple data modalities simultaneously, enabling richer logical analysis. Take a moment. What is your answer? The correct answer is option C. Reasoning LLM. It is specialized for logical inference, multi-step reasoning, and drawing verifiable conclusions. Explanation. Reasoning LLMs are specifically designed for tasks that require logical inference, multi-step problem solving, and verifying conclusions, making them ideal for complex test scenario analysis. While instruction-tuned LLMs follow instructions well, they are not specifically optimized for deep multi-step logical reasoning. Foundation LLMs lack instruction-following optimization. Multimodal LLMs add modalities, but not specialized reasoning capability. Low GenAI 1.1.3 K2. Question 14. Learning Objective GenAI 1.1.3. Difficulty level K3. Which of the following tasks would be best handled by an instruction-tuned LLM in a software testing context? Your options are A. Synthesizing dozens of defect reports to identify root cause patterns and recommend priority areas. B. Generating a test report in a precisely defined JSON schema with specific required and optional fields. C. Exploring and generating creative, unexpected test scenarios outside the defined requirements. D. Autonomously deciding which regression tests to skip based on code change impact analysis. Take a moment. What is your answer? The correct answer is option B, generating a test report in a precisely defined JSON schema with specific required and optional fields. Explanation. Instruction-tuned LLMs are specifically trained to follow structured instructions and produce outputs in specified formats. Generating a test report in a defined JSON schema is a classic instruction-following task. Synthesizing defect reports for root cause analysis suits a reasoning LLM. Creative exploration and autonomous decisions require different capabilities beyond instruction following alone. Low GenAI 1.1.3 K2. Question 15. Learning Objective GenAI 1.1.3. Difficulty level K2. What is the relationship between vision language models and multimodal LLMs? Your options are A. Multimodal LLMs are a specialized subset of vision language models focused on text-image integration. B. Vision language models are a specialized subset of multimodal LLMs that specifically integrate visual and textual data. C. Vision language models and multimodal LLMs are unrelated technologies with different underlying architectures. D. Multimodal LLMs and vision language models are interchangeable terms describing the same technology. Take a moment. What is your answer? The correct answer is option B. Vision language models are a specialized subset of multimodal LLMs that specifically integrate visual and textual data. Explanation. Vision language models specifically integrate visual and textual data, making them a specialized subset of multimodal LLMs. Multimodal LLMs have a broader scope and can integrate various data modalities beyond just vision and text. The two are related, not unrelated, and are not interchangeable terms. Low GenAI 1.1.4 K2. Question 16. Learning Objective GenAI 1.1.3. Difficulty level K3. A test team wants to use an LLM to analyze screenshots of a web application's UI during testing and generate descriptive defect reports. Which type of LLM is required for this task? Your options are A. A foundation LLM, because it has broad enough training data to understand visual concepts from text descriptions. B. An instruction-tuned LLM, because it can follow the instruction to analyze images when prompted correctly. C. A multimodal LLM, because the task involves processing both visual, screenshot, and textual, defect report modalities. D. A reasoning LLM, because defect report generation requires logical inference from observed UI state. Take a moment. What is your answer? The correct answer is option C. A multimodal LLM, because the task involves processing both visual, screenshot, and textual defect report modalities. Explanation. Processing screenshots, visual data, and generating text defect reports requires a multimodal LLM, specifically one that can handle both image and text modalities. Foundation LLMs and instruction-tuned LLMs that are text-only cannot process images directly regardless of prompting. A reasoning LLM adds logical capability but still needs multimodal input processing for images. LLM GenAI 1.1.4 K2. Question 17. Learning Objective GenAI 1.1.3. Difficulty level K2. Which of the following is a correct use case for a vision language model in software testing? Your options are A. Analyzing large volumes of structured test execution log files to identify failure patterns. B. Generating optimized SQL queries for test database population based on schema descriptions. C. Comparing UI screenshots from test runs against baseline screenshots to identify visual regressions. D. Synthesizing multiple text-based test reports into a single executive summary document. Take a moment. What is your answer? The correct answer is option C. Comparing UI screenshots from test runs against baseline screenshots to identify visual regressions. Explanation. Comparing UI screenshots against baseline images is a visual task that directly leverages the vision language model's ability to process and reason about image data alongside text. Log file analysis, SQL generation, and text report synthesis are text-only tasks that do not require visual processing capabilities. LLM GenAI 1.1.4 K2. Question 18. Learning Objective GenAI 1.1.4. Difficulty level K2. Which of the following best describes key capabilities of LLMs in software testing tasks? Your options are A. Analyzing and clarifying requirements for ambiguities and generating diverse test data including boundary values. B. Generating complete production-ready application code and directly executing automated test scripts without human oversight. C. Performing manual exploratory testing autonomously and replacing human decision-making in high-stakes scenarios. D. Fully automating test script execution and providing creative insights through manual testing processes. Take a moment. What is your answer? The correct answer is option A. Analyzing and clarifying requirements for ambiguities and generating diverse test data including boundary values. Explanation. LLMs can analyze requirements to identify ambiguities and inconsistencies and can generate diverse test data including combinations and boundary values. LLMs cannot generate complete application code independently, directly execute test scripts without oversight, perform manual exploratory testing autonomously, or replace human decision-making. LLM GenAI 1.2.1 K2. Question 19. Learning Objective GenAI 1.1.4. Difficulty level K3. A tester asks an LLM to help identify gaps and inconsistencies in a functional requirements document before test design begins. This is an example of which LLM capability for testing? Your options are A. Test execution. The LLM runs test cases against the requirements automatically. B. Requirement analysis. The LLM reviews requirements to identify ambiguities, gaps, and inconsistencies. C. Code generation. The LLM generates the application code that satisfies the requirements. D. Defect prediction. The LLM calculates the statistical probability of defects based on requirement complexity. Take a moment. What is your answer? The correct answer is option B, requirement analysis. The LLM reviews requirements to identify ambiguities, gaps, and inconsistencies. Explanation. Identifying gaps and inconsistencies in requirements is a core LLM capability for requirement analysis in testing. LLMs cannot execute tests, generate production application code, or statistically predict defect counts from requirements. Requirement analysis, identifying ambiguities, and missing coverage is one of the primary testing applications described in the CT-GenAI syllabus. Low GenAI 1.2.1 K2. Question 20. Learning Objective GenAI 1.1.4. Difficulty level K2. Which of the following describes a limitation of LLMs when supporting software testing activities? Your options are A. LLMs cannot process natural language requirements documents. B. LLMs cannot suggest test case ideas or generate test data. C. LLMs cannot directly execute test scripts or make autonomous high-stakes testing decisions. D. LLMs cannot review or summarize test execution results. Take a moment. What is your answer? The correct answer is option C. LLMs cannot directly execute test scripts or make autonomous high-stakes testing decisions. Explanation. LLMs cannot directly execute test scripts that requires integration with test execution tools and should not make autonomous high-stakes testing decisions, as human oversight is required. LLMs can process requirements, suggest test ideas, generate test data, and summarize results. The key limitation is around execution and autonomous decision-making. Low GenAI 1.2.1 K2. Question 21. Learning Objective GenAI 1.1.4. Difficulty level K2. Which of the following correctly illustrates an LLM generating test data for software testing? Your options are A. An LLM runs a regression test suite and records pass-fail status for each test case. B. An LLM reads production database records to populate test environments with real customer data. C. An LLM generates a set of input values covering valid, invalid, boundary, and equivalence partition cases for a login form. D. An LLM deploys test automation scripts to a CI/CD pipeline and monitors execution results. Take a moment. What is your answer? The correct answer is option C. An LLM generates a set of input values covering valid, invalid, boundary, and equivalence partition cases for a login form. Explanation. Generating input values covering valid, invalid, boundary, and equivalence partition cases is a direct example of the LLM test data generation capability described in the CT-GenAI syllabus. Running tests, reading production databases, and deploying to CI/CD pipelines are execution and infrastructure tasks that LLMs do not perform directly. Low GenAI 1.2.1 K2. Question 22. Learning Objective GenAI 1.2.1. Difficulty level K2. Which statement best differentiates AI chatbots from LLM-powered testing applications? Your options are A. AI chatbots are optimized for specific test tasks while LLM-powered testing applications are designed for general ad hoc interactions. B. AI chatbots and LLM-powered testing applications offer identical functionality with only minor interface differences. C. LLM-powered testing applications use conversational interfaces while AI chatbots integrate directly into test processes and tools. D. AI chatbots provide conversational interfaces for ad hoc interactions while LLM-powered testing applications deliver customized solutions integrated into specific test processes. Take a moment. What is your answer? The correct answer is option D. AI chatbots provide conversational interfaces for ad hoc interactions while LLM-powered testing applications deliver customized solutions integrated into specific test processes. Explanation: AI chatbots are best suited for ad hoc, conversational interactions and do not require integration into test tools or processes. LLM-powered testing applications are purpose-built to integrate into test processes, providing customized solutions for specific testing needs. The two serve distinct purposes and are not interchangeable. LLM-GenAI 1.2.2 K2. Question 23. Learning Objective GenAI 1.2.1. Difficulty Level K3. A test organization is considering whether to use a general-purpose AI chatbot or a dedicated LLM-powered testing application for their continuous integration pipeline. Which factor most strongly favors the LLM-powered testing application? Your options are A. The chatbot requires a paid subscription while the LLM-powered testing application is open source. B. The LLM-powered testing application integrates directly with CI/CD tools and test management systems, providing automated, process-integrated outputs. C. The chatbot can only process text while the LLM-powered testing application can process images and logs simultaneously. D. The chatbot lacks internet connectivity, while the LLM-powered testing application can retrieve live defect data. Take a moment. What is your answer? The correct answer is option B. The LLM-powered testing application integrates directly with CI/CD tools and test management systems, providing automated, process-integrated outputs. Explanation: the defining advantage of an LLM-powered testing application over an AI chatbot is its direct integration into test processes and tools, including CI/CD pipelines, test management systems, and defect trackers. This enables automated, structured, process-integrated outputs rather than ad hoc conversational responses. Subscription cost, modality support, and connectivity are not the defining syllabus-relevant differentiators. LLM-GenAI 1.2.2 K2. Question 24. Learning Objective GenAI 1.2.1. Difficulty Level K2. Which of the following describes an appropriate use of an AI chatbot for a software tester? Your options are A. Automatically generating and committing Gherkin test cases to a version control system after each sprint review. B. Continuously monitoring test execution pipelines and triggering reruns when flaky tests are detected. C. Quickly drafting a test plan outline during a planning meeting by having an ad hoc conversation with the chatbot. D. Integrating directly with the bug tracking system to create, assign, and close defect tickets automatically. Take a moment. What is your answer? The correct answer is option C, quickly drafting a test plan outline during a planning meeting by having an ad hoc conversation with the chatbot. Explanation. Ad hoc, conversational use during a planning meeting, like quickly drafting a test plan outline, is exactly the kind of use case that AI chatbots are designed for. Auto-committing to version control, monitoring CI/CD pipelines, and integrating with bug tracking systems all require integration capabilities that belong to LLM-powered testing applications, not general-purpose chatbots. Low GenAI 1.2.2 K2. Question 25. Learning Objective GenAI 1.2.1. Difficulty level K2. Which of the following most accurately describes a key feature that distinguishes an LLM-powered testing application from an AI chatbot? Your options are A. LLM-powered testing applications always require cloud connectivity, while AI chatbots can function offline. B. LLM-powered testing applications include a customized system prompt and workflow integration that shapes responses specifically for testing tasks. C. LLM-powered testing applications are restricted to testing activities, while AI chatbots can answer questions on any topic. D. LLM-powered testing applications are trained exclusively on testing domain data, giving them superior accuracy. Take a moment. What is your answer? The correct answer is option B. LLM-powered testing applications include a customized system prompt and workflow integration that shapes responses specifically for testing tasks. Explanation. LLM-powered testing applications are distinguished by their use of customized system prompts, testing-specific context, and direct workflow integration with test tools and processes. This makes them purpose-built for testing rather than general purpose. Cloud versus offline availability, topic restriction, and exclusive training data are not the key differentiating characteristics described in the CT-GenAI syllabus. Low GenAI 1.2.2 K2. Question 26. Learning Objective GenAI 1.2.2. Difficulty level K1. According to the AI capability spectrum in the CT-GenAI syllabus, which sequence correctly orders the 4 AI techniques from earliest, most constrained, to most recent, most generative? Your options are A. Deep Learning Symbolic AI Classical ML Generative AI. B. Symbolic AI Classical ML Deep Learning Generative AI. C. Classical ML Symbolic AI Generative AI Deep Learning. D. Generative AI Deep Learning Classical ML Symbolic AI. Take a moment. What is your answer? The correct answer is option B. Symbolic AI Classical ML Deep Learning Generative AI. Explanation. The AI capability spectrum progresses from symbolic AI, rule-based, oldest, classical machine learning, data-driven pattern recognition, deep learning, neural networks, automatic feature extraction, generative AI, creates new content, most recent and generative. This ordering reflects the historical development and increasing generative capability of AI techniques. Low GenAI 1.1.1 K1. Question 27. Learning Objective GenAI 1.1.2. Difficulty level K3. A test engineer uses an LLM to help write a summary of 500 API test execution results, but notices the summary omits results from the first 200 tests. What is the most likely cause? Your options are A. The LLM applied tokenization incorrectly, splitting API result entries across token boundaries. B. The LLM's temperature setting was too high, causing it to randomly skip early sections. C. The 500 results exceeded the LLM's context window, causing the earliest results to be dropped. D. The embedding vectors for the first 200 results were too similar, so the LLM merged them together. Take a moment. What is your answer? The correct answer is option C. The 500 results exceeded the LLM's context window, causing the earliest results to be dropped. Explanation. When input data exceeds the LLM's context window, the model can only process what fits within the window. Tokens or sections that exceed the limit are dropped. This explains why the first 200 results, the oldest part of the input, were omitted from the summary. Temperature affects output randomness, not content omission. Tokenization splits text but doesn't discard content. Embedding similarity doesn't cause omissions. Low GenAI 1.1.2 K2. Question 28. Learning Objective GenAI 1.1.3. Difficulty level K1. Which of the following is not an example of a multimodal input that an LLM with multimodal capabilities could process? Your options are A. A screenshot of a failing UI test alongside a text description of the expected behavior. B. An audio recording of a usability testing session combined with a text transcript. C. A network packet capture file from a performance test run. D. A diagram of a system architecture alongside a text prompt asking for test coverage suggestions. Take a moment. What is your answer? The correct answer is option C. A network packet capture file from a performance test run. Explanation. A network packet capture (PCAP) file is binary protocol data. It is not a standard modality, image, text, audio, video, that multimodal LLMs process. Screenshots with text, audio with transcripts, and diagrams with text prompts are all standard multimodal combinations that vision language or multimodal LLMs can handle. Processing PCAP files would require specialized binary parsing tools, not an LLM. Low GenAI 1.1.4 K2. Question 29. Learning Objective GenAI 1.1.3. Difficulty level K2. Which of the following best explains why reasoning LLMs are described as a distinct category from instruction-tuned LLMs in the CT-GenAI syllabus? Your options are A. Reasoning LLMs are trained on more data than instruction-tuned LLMs, giving them broader general knowledge. B. Reasoning LLMs are specifically optimized for logical inference, step-by-step problem solving, and synthesizing information beyond just following instructions. C. Reasoning LLMs do not require instruction following capability, they only process structured data inputs. D. Reasoning LLMs replace instruction-tuned LLMs for all testing tasks because they produce more accurate outputs. Take a moment. What is your answer? The correct answer is option B. Reasoning LLMs are specifically optimized for logical inference, step-by-step problem solving, and synthesizing information beyond just following instructions. Explanation. Reasoning LLMs are a distinct category because they are specifically optimized for logical inference, multi-step problem solving, and synthesizing complex information capabilities that go beyond instruction following. An instruction-tuned LLM excels at following instructions and formatting. A reasoning LLM excels at working through complex analytical chains. They are complementary, not replacements for each other. Low GenAI 1.1.3 K2. Question 30. Learning Objective GenAI 1.1.2. Difficulty level K3. A tester asks an LLM to generate 50 unique usernames following a pattern, but the LLM starts repeating patterns after 30 entries. Which concept best explains this degradation in output quality? Your options are A. The LLM's temperature is set to low, causing it to default to the most probable tokens from early in the sequence. B. The generated tokens from earlier in the response are approaching the context window limit, reducing the model's ability to maintain diversity. C. Tokenization errors are causing the LLM to misinterpret the pattern definition after the 30th entry. D. The embedding vectors for usernames naturally converge after 30 entries, forcing the model to repeat. Take a moment. What is your answer? The correct answer is option B. The generated tokens from earlier in the response are approaching the context window limit, reducing the model's ability to maintain diversity. Explanation. As the LLM generates more tokens, the growing output itself consumes the context window. Beyond a certain point, the model has less room to reference the diversity already generated, which can lead to repetition. Temperature affects randomness, but the primary cause here is context window constraint reducing the model's ability to track what has already been generated. Low GenAI 1.1.2 K2. That's all 30 questions for Chapter 1, Introduction to Generative AI. Well done for completing this chapter. If this helped, please like the video and subscribe to AmitAutomates for the next chapter in the series. The full CT-GenAI playlist covers all 5 chapters across 6 videos. Good luck with your ISTQB exam.